How are you guys doing today?
Good.
Good. Good? Okay, what seems to be the problem?
Well, I've noticed he's been becoming very weak. When he sits on the ground, he is having a very hard time picking himself up. His coordination is a little off. When he walks, he tends to stumble or waddle.
Okay.
And I have noticed he is gaining a little bit of weight.
Okay. Well, I just want to do a little test for you. Can you get on the ground for me and then try to stand back up?
Sure.
Alright. Just help you down. Alright, and just try to stand back up for me. Okay. Alright, you can have a seat again. Okay, well, I'm just going to take some blood from you, and then I'm going to run a few tests on it and see if we can figure out what's wrong, okay?
Sure.
Okay.
Thank you.
How you doing today?
Hey, how you doing?
Good. I've got a 4-year-old male patient that his mom came in and he said he was getting weaker, gaining some weight. And I did a test and he was having a lot of trouble getting up.
Okay.
And it looks a lot like Duchenne's muscular dystrophy. I was wondering if you could run some tests for me and see if that's right.
Alright, sure. I'll just run the genetic test to see if there are any gene deletion or duplications.
Okay.
But the test is not entirely accurate, so we might need a tissue biopsy later.
Okay.
Alright.
Hey guys, I just went to the lab and I had some DNA tests run, and it confirmed that your son does have Duchenne's muscular dystrophy. And what that is, it's an X-linked recessive genetic disorder. And what that means is it's tied to a gene on your X chromosome. And males have an X chromosome and a Y chromosome. So this disorder is going to affect your X chromosome, and because you only have one of them, you're not going to have another gene on your other X chromosome like women do to be able to counteract the mutation you have on the only X chromosome you have. It's a mutation in a gene called XP21, which actually codes for a protein called dystrophin. And this protein gives some stability to the cells and helps them move and stuff. And when that's absent, like in this disorder, we see a lot of weakening of the muscles, and it progresses, and eventually your muscles will weaken and not be able to function very well. But we do have some treatments available. We do have some medications, and I'm actually going to prescribe to you prednisone, which is it's a medicine that's going to help your muscle strength and your pulmonary function, and we're going to see if that helps you at all. If that doesn't help, we have another medication called deflazacort, which does the same thing. But mostly what we try to do for this disease is physical therapy and other things like that to try to help. So I'm going to bring in an expert on that to try to explain that to you guys and see what you can do.
Hi, I'm Lisa Turner, and I'm a geneticist. I'm here to explain some more about what's going on at the molecular level. But before I get into that, I wanted to tell you that as this disease progresses, your son will form what are called contractures, where his joints won't be able to move. So in order to prevent that, what we want to do is start him on an exercise of full range, they're called full range of motion exercises, and the physical therapist will be able to explain that to you, which you should find one right away. So we can get braces for him to help keep his muscles or tendons stretched out as long as possible, and also prevent the deterioration of muscles, but eventually he may need surgeries to help relieve the joint pressure. Also, his spine may start curving, and so in order to prevent that, there are also positions he needs to sleep and sit in. And again, the physical therapist will tell you more. Also, again, he may need a surgery later for that, which involves putting metal rods and hooks in the spine, but that's later. So more about the gene therapies for this. Conventional therapies that we have right now are putting a functional form of the dystrophin gene into a plasmid vector or a viral vector and introducing them to the muscle cells, which will hopefully take them up and start producing the functional dystrophin gene. Problem with this is that they're very hard. It's very hard for these vectors to move around the surrounding environment that the muscle cells are in, so they won't get to as many muscle cells as we probably need them to. And also that since we are using viruses and plasmid vectors, there is a chance of an immune response, which we don't want to depress his immune system if we don't have to. So the good news is that there are some new gene therapies that are looming on the horizon, I guess. And one is called utrophin upregulation, and utrophin is a gene that functions in a similar way to dystrophin, so that if we can introduce this gene into the cell, or it's technically already present in the cell, if we can get it to express in higher quantities, it might be able to diminish some of the effects of Duchenne's muscular dystrophy, help strengthen the muscle cells and connection to the cell membrane. But the one that's most promising is called antisense-induced exon skipping, which in effect changes the way how the mRNA transcript of the gene is read, so that instead of producing no dystrophin protein, there'll be at least a functional form, but not fully functional form of the protein produced, which will at least, again, help lessen the effects of Duchenne's muscular dystrophy. So that's what's going on right now. And I want to say that the doctor probably wants to see you again in a week to see how everything's going and to do a follow-up and find a physical therapist for you. But even though this is a life-altering condition, there is still hope out there. Credits. Okay, I'm Jen Laurentini, and I was the very long-winded, geneticist expert person.
Hi, I'm Casey Hager, and I was the mother.
Hi, I'm Jen Zhao, and I'm the son and the lab person.
I'm Chris Dewan, and I was the doctor.